So you've been learning about Prometheus. In a previous video, we've learned how Prometheus works. Prometheus is a powerful time series database that allows us to collect and scrape metrics from anywhere, process it, query it, and send it to external storage. It's pretty much almost a full metric solution. In that video, we created a small Prometheus instance using Docker, and then we have a bunch of microservices and we set up a scrape configuration to scrape metrics from those services. Now, when you run stuff in Kubernetes, you need a pod YAML, which maybe mean that you need a deployment YAML, stateful set YAML, and to expose traffic to that thing, you need a service YAML. You might need storage classes to persist data. You might need a config map. And if you want to manage Prometheus manually, you'd need to write all of the scrape configurations in config maps and manage the entire configuration management yourself. We've also taken a look at sharding and what it takes to manually shard Prometheus instances. You can see the complexities involved with moving containers into Kubernetes and then having to manage all of these Kubernetes objects. Well, this is where the Prometheus operator comes in. Operators and controllers in Kubernetes manages resources for us. The Prometheus operator allows us to manage a Prometheus object instead, and we can apply all of our settings on this object and it'll manage the Prometheus configuration for us. So today we take a look at just that. We'll take a Prometheus instance that we've Dockerized in Docker Compose with a bunch of microservices. We'll move all of this into a Kubernetes cluster and use the Prometheus operator to create our Prometheus instance and set up scraping. After this video, you'll understand the full flow end-to-end using Prometheus in Kubernetes. So grab a drink, sit back, and let's go. So the Prometheus operator is an open source solution that allows us to run Prometheus on top of Kubernetes, and it does all the hard work for us. The first thing that I'm going to do is I'm going to create a Kubernetes cluster using kind. And when I run this command, this will create a 3-node Kubernetes cluster that I can use for testing. When that is done, I can run kubectl get nodes, and now I have my nodes ready to go. Now, thankfully, to monitor the Kubernetes ecosystem with the Prometheus tooling, the Prometheus community has created a bunch of projects that are very useful, starting with one called kube-prometheus. This is a project you will find on GitHub. It's under the Prometheus operator GitHub, and it's the repository called kube-prometheus. And this repository contains a bunch of Kubernetes manifests, Grafana dashboards all out the box, Prometheus rules combined with documentation and scripts to provide and operate end-to-end Kubernetes cluster monitoring with Prometheus using the Prometheus operator. It has all the components you need for a complete Prometheus solution, including the Prometheus operator, highly available Prometheus, alert manager, node exporter to monitor all your nodes in Kubernetes, black box exporter, Prometheus adapter, kube state metrics, and Grafana, as well as a bunch of Grafana dashboards that I'll show you in a bit. Now, if you scroll down on this Git repo, there is a quick start that walks you through how to install these manifests in your cluster. Now, you can either just follow this guide and install the manifest, but if you're using something like Argo and Flux and GitOps tools and you're using something like Helm, they actually recommend you use the community Helm chart. So there's a Helm chart that wraps all of this up neatly so you can just deploy it. And you can find that on GitHub as well. That is under the organization called Prometheus Community under Helm charts. And there are a bunch of Helm charts in this repository. They give you the repository that you can add using the Helm repo add command. So we'll take a look at that Helm chart. The first thing that I'll do is jump into the terminal and paste that Helm repo add command. Once that's added, we can use the Helm search repo command and we can run that on the Prometheus community repository and get the versions of all the Helm charts. You can see there are a bunch of Helm charts that are managed by this community. If we want to take a closer look at that, we can output that to a version.log file. And here you can see all of the charts available. So we got alert manager, more alert manager, and here we have kube-prometheus stack. This is the Helm chart that wraps the manifests in the kube-prometheus repository that we saw earlier. Now there are a bunch of Helm charts in here where you can deploy each component manually if you'd like to, But the recommended way is to just use the kube-prometheus stack, as it gives you everything you need for full Kubernetes monitoring, including the Prometheus operator, which is what we'll need to deploy our own Prometheus instance and set up scraping for our microservices. So what we'll want to do is take note of the chart version over here. So we'll deploy this version of the Helm chart, and this is the chart name. One other thing that I like to do is also print out the values that the Helm chart supports. This gives me an idea of everything I can override and configure. Things like node selectors, how many instances of the Prometheus operator we want, the scrape intervals, how often we want our Prometheus to scrape, and basic things like that. So I jump into the terminal and then I just run the helm show values command for that specific Helm chart, and I can output that to a values file. Go ahead and run that command, and this values file is a bajillion lines long. See, almost 5,500 lines, and this gives us all the options we can configure things. You can load in extra Grafana dashboards if you wanted to, extra Prometheus or Grafana data sources. You can set up full high availability over here. Basic things like overriding the name, so if you don't like the default names, you can override the full names of all the resources. Here are all the CRDs. So this value here enables the Prometheus operator CRDs, which is required because this gives us the custom YAML we'll use today. You've got custom rules, default rules. You've got some global rules, like if you want to customize your own registry to use instead. So here you got all the different components. You got Prometheus Windows Exporter, you got Alert Manager configuration, you can configure Grafana, you can configure service monitors, Kubernetes API, kubelet scraping, kube controller manager, core DNS, kube DNS, kube etcd, the kube scheduler, kube proxy, kube state metrics, kube's node exporter, the Prometheus node exporter subchart. You can configure the Prometheus operator, the default Prometheus instance, and it goes into Thanos settings as well. So let's create a basic values file, and I'll show you some of the basics I like to override. So this is what my basic values look like. I just override the name. I disable Alert Manager for this demo because I won't be using it. I enable Grafana. I override its full name. I give it a node selector. This is if you're running different nodes in your Kubernetes cluster. I give it just a default password here for testing purposes. And then I do the same thing for the Prometheus operator. Give it a node selector. Give kube state metrics a node selector. Give the kubelet a scrape interval. So you can do things like set scrape intervals on each of these objects. If you don't want to scrape them too often, or maybe you want to scrape them more often, you can do that right there by setting these intervals. Here I set the default setting for the Prometheus instance. I can set things like defaults for the retention. So I want to keep metrics for 30 days. Here's my node selector. And then I have Prometheus node exporter enabled as well. And I just set an interval on that. So this just showcases basically how you can override things in the Helm chart, and you can customize this to suit your needs. And what I'm going to do is just set the Helm chart version that we grabbed earlier, set that in a variable so I can use that quite easily. And then I'm going to say helm install. I'm going to install the kube-prometheus stack chart, the version I want. I'm going to create a new namespace called monitoring, and I'm going to pass in my values file there. Go ahead and run that. And that will go ahead and deploy the Helm chart to my cluster. It also prints out details on how to get the Grafana secret if you need to, the default password. But I've already set that in my Helm values, so I don't need that. And this will tell you how to access the Grafana local instance, which we'll do in a little bit. So now in our cluster in the monitoring namespace, we should have a bunch of pods up and running. So it has our Grafana instance. We have kube state metrics. This guy will basically go ahead and help us collect pod and container and workload metrics from the cluster. And then we have node exporter. That's a daemon set running a pod on each node, giving us full visibility of every node in our Kubernetes cluster in terms of Linux metrics. So things like CPU, memory, disk, and network of every node in the cluster. So you can see if there's any contention and how each node performs. Probably one of my favorite parts of Prometheus. Then we have our default Prometheus instance over here, and then the Prometheus operator. So with the Prometheus operator now deployed, the CRDs are in our cluster. So what is CRDs? CRDs are basically custom YAML. So if you're familiar with like kind pod, kind deployment, kind config map, this will add new resources to our cluster called kind Prometheus. And one important thing is the kind Prometheus will give us a Prometheus instance, but we know from previous videos that we need scrape configuration to go and scrape endpoints. For this, it adds a new object called kind service monitor. We can see service monitors in our cluster now after deploying that Helm chart. There's a bunch of them in the monitoring namespace. Grafana, Prometheus Stack API Server, Core DNS, Kube Controller Manager, Kube etcd, Kube Proxy, Scheduler, Kubelet, and Prometheus. These are all scrape configurations. A service monitor basically points to a Kubernetes service in order to scrape the metrics. So we know that the API server, Core DNS, and all of these components in Kubernetes generate metrics. They all have metrics endpoints. So in order for the default Prometheus to go ahead and scrape these, all these service monitors are deployed by default. So service monitors point automatically to services to scrape by using label selectors. And the Prometheus operator facilitates basically using these service monitors, working out what services to scrape, and then configuring Prometheus configuration. Basically, it configures Prometheus scrape config behind the scene. And then it'll also hot reload that configuration in our Prometheus instance so we don't have to restart any pods. As an example, I can go to my terminal and I can say kubectl and use the describe command on a service monitor called node exporter. If I do that, you'll see that it has this selector here. It tells me what it's going to select, so it will match the labels on Kubernetes services with these labels. So it basically picks up the Prometheus node exporter Kubernetes service, and it's looking specifically for this endpoint. The service monitor also has a scrape interval, as we configured our Helm chart to scrape every 120 seconds. That's just an example. Generally, you want to scrape more frequently so that your metrics are more accurate, and you don't miss out on spikes, things like CPU spikes. We can port forward and view the dashboards by port forwarding to the Grafana instance. Then I can head over to localhost port 3000, I can log in with the admin password, and then I am in. And under dashboards, you'll see there's a bunch of Kubernetes default dashboards which you can use to monitor your Kube API server, compute resources like nodes and pods and workloads, Kubernetes core components like the controller management, Kubelet, and there are a lot more dashboards available. So now our monitoring infrastructure is ready to go. We can now use the Prometheus operator to deploy our own Prometheus instance and then set up service monitor to scrape our microservices that we've deployed to our cluster. In the previous video, when we've taken a look at how Prometheus work, we had Prometheus running in a local Docker instance, scraping local microservices. We have a Golang, .NET, Python, and Node.js service. I'm going to quickly show you how to build those by using Docker Compose. So I simply run Docker Compose build and I point to that compose file we used in the previous video. That'll go ahead and build all of those microservices in different programming languages. So that will build our .NET, Go, Node.js, and Python application. And next up, I'm going to load all those Docker images into my kind cluster because I don't have an image registry to use. So it's easier for me to just use the kind load command and load all of these images into our cluster. So I go to the terminal and paste each one of those, and that'll load them into the cluster. This is great for testing because you don't need a container image registry and you don't need to push everything to Docker Hub for testing purposes. Next up, I'm going to deploy our microservices. So these are just simple Kubernetes deployment with a service to expose each deployment. And I have one kubectl apply command for every programming language: Go, .NET, Python, and Node. So I go ahead and copy that, jump into my terminal and paste it. And as you can see, that'll create a deployment as well as a service. So simple microservice architecture. So you have a deployment with 1 or 2 pods, and then you have a service sitting in front exposing those pods. Then if I do kubectl get pods, we can see our microservices are now all up and running. I can do kubectl get services and I can see all my services are up and running. The services are all running on port 80 and the microservices are all running on port 5000, just like we had in our Docker Compose file in the previous video. Now that we have a cluster that's ready to be monitored, we have a bunch of microservices running, we'll want to create a separate Prometheus instance. Maybe you want to create one per namespace, one per department, or you want just one to rule them all. This is up to you. I find it better to deploy maybe one per namespace, because that means you don't have to have one giant instance, and you can have a Prometheus for each purpose. So I'll deploy a Prometheus in the default namespace, go ahead and configure it, but in order to do so, we need a service account. Prometheus needs to be able to scrape services, and in order to do so, it needs a bit of RBAC. So what I have is a Kubernetes service account called Prometheus Applications. I'm going to call my Prometheus just this name so that it's easy to identify, and its purpose is to scrape application custom metrics. So that is my name of my service account. Then I give it a cluster role. The cluster role just means it's able to list, get, and watch these Kubernetes resources, as well as these different API groups and resources like endpoint slices and ingresses. That's the permission at a cluster level, and then a role binding to bind that permission to the service account. On the Prometheus operator website, you'll find a link to the docs page, and in here you have an introduction guide, getting started, installing the operator. This all points to everything we've just seen in this video. Then you have a platform guide, which pretty much shows you what we've walked through by setting up Prometheus and setting up a Prometheus instance. If you click on getting started under the platform guide, you'll see the guide for deploying a Prometheus instance, and this is pretty much creating a service account and then creating the cluster role and the role binding, just like we did earlier, as well as setting up a bare bones basic Prometheus instance. So I just wanted to show you that the documentation is pretty much what I followed in this guide. So then I jump to my terminal and I just apply that service account YAML. That'll create the service account and the cluster role and role binding. Then I'm going to go ahead and create a Prometheus instance. And for this, I need a Prometheus YAML. So I say kind Prometheus. I'm going to call everything in this video Prometheus applications. And here are some of the settings that I like to use. First one is evaluation interval. This means that every time I make a change to service monitors, this Prometheus will evaluate all of these things for the configuration every 30 seconds. You can set an image with the version of Prometheus you want to use, node selectors, different log formats and log levels for this instance. And here you can set a pod monitor. Now, I won't be using pod monitors in this video, but it's pretty much exactly the same as a service monitor. Pod monitors allow you to monitor individual pods, but because we use deployments and stateful sets and those sort of things, and we expose it with a service, I'll be using a Kubernetes service instead. Here I set my replica to 1, my retention to 30 days. I'd like to keep metrics for 30 days. And this depends how you set up high availability. If you're simply using this Prometheus instance to collect metrics, you might need a lower retention if you're forwarding those metrics elsewhere. And here's the default scrape interval, how often you want this Prometheus instance to go ahead and scrape service monitors that don't have a custom interval. Here's our service account name that we'll be using, the service account we created earlier, and then I have my service monitors. Now there's two fields here. The first one is the service monitor namespace selector. And specifically, I'm using match label, and I'm matching the name of the default namespace. So here you can say this Prometheus instance needs to look after every service monitor in the default namespace. And then you can also be more specific to say, I want to look for service monitors in the default namespace that have the monitoring label as Prometheus applications. This means when my developers deploy their apps, they need a service monitor with this label on it. That is how you configure scraping. If this is misconfigured, you'll go to your Prometheus instance and you won't see anything under service discovery. We'll take a look at that in a bit. Next up is the shards. The default is just one shard, and this goes back to my sharding guide. If you take a look at the how to do basic sharding in Prometheus, Prometheus uses basically a hash mod modulus algorithm to work out sharding between instances. And basically everything we learned in that video is automated here by just setting shard and a number, how many shards you want. and then the version of Prometheus. So then I jump to the terminal, press enter, and deploy my Prometheus instance. When I do kubectl get pods now, we'll see that there is a Prometheus pod up and running. This has been automatically created by the Prometheus operator now. Next up, to set up scraping to the microservices, we'll be creating service monitors. And this is what service monitors look like. I have a service monitor here for each one of my applications. You can see I have a service monitor here for the .NET, a service monitor here for Go, a service monitor here for Node, and a service monitor for Python. And basically what this does is just a simple copy paste 4 times with different names, and this selects what service to scrape. So our microservice, each one of them has a service, and they have the label called app with the name of the service there. So we'll be using that to select the service to scrape and then give the endpoint name we want to scrape. The cool thing about Service Monitor, you can actually do endpoints and you can say the name of the endpoint. So I can give the name of the service port rather than the number. So if the microservice changes its port, we don't have to worry about changing the Service Monitor. And I pretty much follow this exact same thing on each one of these services. And to deploy that, I'm simply going to apply the service monitor.yaml, and now we're good to go. We can go ahead and port forward to that Prometheus instance on port 1990. And if we go to localhost port 1990, you can see we have the Prometheus instance right here. And if you drop down the status, click on Service Discovery. And this is where your service monitors will show up. Now to refresh this, because remember our evaluation is every 30 seconds, so it will take up to 30 seconds to populate. And here's our .NET, Go, Node.js, and Python service monitor. You want to be able to see these show up. Then you know your selector on your Prometheus instance is correct. Now to check whether each service monitor is correct and correctly scraping the endpoint, you hop into the targets page. So go status, target health, and you should see all of these endpoints. And you should also see the last scrape and the state, whether they're up or not. And here you'll see things like connection refused. If you've got the port number wrong or anything like that, you'll see the error over here. So this allows you to monitor your service monitors and make sure they're working. So now we know our metrics are in Prometheus. Now, just for fun, I can go to Grafana as well. I can port forward to the Grafana instance. I can go to data sources. Here we have the default Prometheus that came with the Helm chart. I can head over to add a new data source. I can select Prometheus. I can just call this one Prometheus applications. The connection is going to be HTTP Prometheus operated.default because it's in the default namespace, port 1990. And then I'm going to head right to the bottom and click on save and test. You can see that's successful. Then I'm going to head up to dashboards. On the top right, I'm just going to say new, import dashboard. I'm going to click on import and I have a custom dashboard over here. Going to go ahead and load that. And then very important, I need to select my Prometheus that I've just added and say import. This will load up a very basic dashboard that I created showing request per second and request duration for each one of the services. It has Netcore, Node.js, Golang, and Python. Now, if you wanted to follow along, the source code for this guide is in the Docker Development YouTube series GitHub repo, and the link to that is down below in the description. If you expand that and you look under the monitoring folder, you'll find a Prometheus folder and you'll find a README. This is the Prometheus monitoring application guide where we walk through how Prometheus works, getting everything running up in Docker Compose. If you want to take a look at everything we've done in this video, you go to the source code. In the monitoring Prometheus folder, there is a folder called Kubernetes and there's a 1.33. This is the latest one at the time of this recording. There's a README inside there. This will take you to the Kubernetes 1.33 monitoring guide. Create a cluster with kind. Follow the kube-prometheus guide, the community Helm chart, followed by Helm install, and all the steps we've taken a look at today. That'll get you the cluster monitoring, and to follow everything for the Prometheus operator, once you have the cluster monitoring up and running, you'll check out the source code. In the monitoring folder for Prometheus, we have Kubernetes. In that folder, we have the Prometheus operator and a README in there. This is the Prometheus operator guide that I followed in in this video after setting up cluster monitoring. This will give you all the applications to monitor, which you can build with Docker Compose, the kind load commands, and the YAML to deploy all the microservices, and then create your own Prometheus instance and scrape all the microservices with service monitors, as well as the Grafana setup that we have. So that's all the source material if you want to take it for a spin. Hopefully this video helped you, send you in the right direction for running Prometheus on top of Kubernetes. If you liked the video, be sure to like and subscribe, hit the bell, and if you want to support the channel even further, hit the join button down below to become a YouTube member. And as always, thanks for watching, and until next time, peace.